In this video, we're going to be solving a rotation problem where we solve for the linear acceleration of a yo-yo. So if we analyze the forces acting on the yo-yo, we have the force of gravity, which is mg pulling straight down from the center of mass of the yo-yo. And then we also have this force of tension pulling upwards this way, which we'll just go ahead and call T. Now, when you're analyzing the forces, just like we normally would, we would sum up the forces and then use Newton's second law and say that the sum of the forces equals the mass times acceleration. Now, for this one, it ends up being a pretty simplistic answer, but we want to make sure we use a few different formulas to analyze this. So we're going to have to also use torque equals I alpha, which is the rotational equivalent of this formula over here. Now, for the torque, we have the torque of tension over here, and then the torque of tension is going to be the tension times r, which is the radius of the yo-yo, so the distance from here to here. And then from there, we have the I value. The I value is the moment of inertia of the yo-yo, and the yo-yo being a solid disk would have the formula 1/2 r squared. Now for the alpha, we're going to have to do a little substitution. We know that alpha is equal to the linear acceleration over r. So if we take that and substitute it in right over here, then we're going to have an a over r over here. And that's good because we are looking for linear acceleration and we will get some stuff to cancel. So that's going to be beneficial to us. So we have this r canceling out one of these, and then this r canceling out this one from both sides. So in the end, the tension is equivalent to 1/2 m times a. Now what we can do is go back to the sum of forces and Newton's second law. And if we say the whole entire system is, or the yo-yo itself is going to be accelerating downwards, I'll just call this the positive direction and then this the negative direction, although we normally do the opposite of that. And then with that being said, we have mg pulling it down, and then we are being counteracted by the force of tension, which is 1/2 ma, which we obviously just found right over here. And that would equal the mass of the yo-yo times the linear acceleration. Now, when we do that, if we go ahead and simplify that, our masses are going to drop down, or drop out, excuse me. Then if we add 1/2 a to just a single 1a, then we would have g equal to 3/2 a. And then we want to solve for the linear acceleration, actually. So I'll think about it as sort of like a cross multiply a little bit, is where we're going to cross the 2 up and then cross the 3 down. And then that would mean 2/3 of g is equal to the linear acceleration. So that's quite simplified from all the things that we had before. The mass isn't significant and the radius isn't significant. So in any case where you have a yo-yo that is rolling down but affected by the force of tension, it's going to get restricted and not get the full value of g. It's going to be 2/3 g. And then if you also had a problem sort of similar to this, where it maybe be holding the end of a toilet paper roll and letting it unroll and then having a negligible change in mass, then you would have the same sort of thing. If the mass is changing for the toilet paper problem, then it becomes sort of a different problem. But for a simple yo-yo question or a toilet paper question with a negligible loss in mass, you can go ahead and say it's 2/3 of g. So I hope that was helpful to you. Thank you for watching.